Hey everyone, welcome to Courtside View. And this is the episode 5, but part 2 of episode 5. Uh, I have Katie Roberts from Neo4j and I have Ted Johnson from QIAGEN. And in the previous episode, we are discussing enterprise scale knowledge graph and we are talking about certain example. What we talked about for that, please check our part 1 of the same episode. But Ted, you're talking about giving us some certain example of Parkinson disease, Betweenness and Centrality, and then I really thought that was an incredibly insightful example. And for those our listeners who want to start building and analyzing knowledge graph in their work, Katie, I have a question to you. Where should they begin?
Yeah, so I think, the most basic starting point would be looking at the resources on the Neo4j website. There's really a lot of rich information there, including use case details, customer stories, documentation, and video tutorials. I also highly recommend graphacademy.com, which is also an offering that Neo4j provides that gives you free, self-paced and hands-on courses, so you can actually get to know about graph and how to interact with graph, as well as graph data science using real examples and real queries. And then there's also kind of a rich set of community events that we will have linked on our website as well. So this summer we're having a Graph Summit series, which is an in-person kind of day that's all about graph. And then in the fall, we have a really cool online conference called Nodes that is like 24-hour global event that has both perspectives from Neo4j as well as a lot of our customers and community. And so there's always really interesting stories that come out of that, or both events, in terms of using graph in real world scenarios. So that's kind of where I would start off.
That's awesome. And Ted, if you can help us a little bit, where would people look into if they're interested in here?
Yeah. Yeah. For the Neo4j part, I can attest to Graph Academy. That's where I started, more than 6 years ago. And it really launched me into this world of graph databases and graph algorithms. And yeah, I think it's a powerful tool, and I'd recommend it to anyone who's just thinking getting started in this space. When you're thinking about starting a knowledge base around, biomedical knowledge, I've mentioned our biomedical knowledge base a few times now, right? And it really is a powerful set of curated data. We've had, PhD scientists going over the biomedical literature for the last 20 years. There's thousands, hundreds of thousands of human hours that have gone into that curation, the thought about building out the appropriate ontology, linking all the correct elements. So I would encourage people who are thinking about building out their own internal knowledge base to think about starting with BKBHD. Get that solid foundation. And then, with tools like Neo4j, you can really start extending that. So if you have, internal proprietary knowledge and you want to think about how to link that into your own data, we're happy to supply BKBHD and let you explore that on your own. We also have great field application scientists and services team members who would love to help you, figure out that data modeling and engage with you to make sure you're really getting the most out of your graph projects. So
That's awesome. So what I hear, please check out graphacademy.neo4j.com or head to digitalinsights.qiagen.com or connect with our team for custom demos and pilot projects if you're interested. And in the previous episode, we talked about like various examples. Katie provided us a great example about target prioritizations. Ted provided an example about Parkinson's disease and Betweenness and Centrality. If I have to ask this to you, Katie or Ted, if you want to summarize the episode, the part 1, how do you do it? Do one of you want to go?
Sure. I can give it a shot. So we kind of just did a really brief intro into graphs and graph data science. And then I think some of the highlights were thinking about the new insights and perspectives that graphs and graph algorithms can provide, which kind of led into the stories that both Ted and I were discussing in terms of being able to kind of both flexibly run analytics on your data using the graph data science package, and kind of how that's nice and easy for data scientists in terms of not having to do a ton of ETL or moving data around and writing complex queries. So kind of natively doing graph analysis in a graph is nice. And then also the kind of additional gain that you get from focusing on these relationships and being able to kind of pull that thread of discovery on top of the knowledge that you already are representing in the graph. So I think Ted's story was really nice around that as well, from that perspective of finding a potential new association, between Parkinson's and heartburn. And so that's kind of where graph algorithms are really exciting, is that, it goes beyond just representing the knowledge of today and then starts sending you in the direction of what you can learn and explore tomorrow. So.
Yeah, I think that was an excellent summary. And I would extend, I suppose, to say that I think as a person in pharmaceuticals or biotech, we're really interested in the relationships between entities, and the toolkit available through Neo4j, through graph databases, through the graph data science module especially, really lets you try to use those tools to do things like understanding bottlenecks, where in pathways are signals converging, right? And is that maybe something you want to target to maximize the effect of your drug product or your intervention, right? Also, when we're thinking about things like adverse events, with cimetidine, that this unexpected link it might have to something like Parkinson's. I think that's something a lot of folks are interested in. Can we know beforehand, what these maybe unconventional or unexpected risks of a given intervention might be? That maybe without this connected information, we might not be able to find, we might not think to look for. So I think there's some powerful tooling there that really leverages the structure of the data. Not just that we know things about these entities, on a one-off basis, but actually that ability to work through the structure of the data to find new information is very powerful.
Thank you. That's awesome summary. Katie and Ted, thank you both for joining us and sharing your expertise. It's super clear that the data science with graphs is opening a very powerful new frontier in biomedicine. And thank you to our listeners. We hope today's episode and the previous one, part one, sparked ideas and inspiration for your work. And do not forget to subscribe our Courtside View, follow us on LinkedIn, give it a follow to Neo4j, reach out to Katie, reach out to Ted or me if you have any questions. And join us next time for more insights at the cutting edge of data science. Until then, keep asking bold questions and keep exploring the connections. With that, thank you, Ted. Thank you, Katie. Bye.
Thank you.
Thank you.
Bye.
QIAGEN. Sample to insight.